Hello everyone. Welcome to the new session of the 5G non-standalone training. Today would be session number 6. In the previous sessions, if you can recall, we have covered the first part, which was related to the end-to-end signaling analysis guide, where we went through the 5G NSA accessibility and returnability, which is the drop rate, for example, and the mobility. During these 3 sessions, we explored mainly 2 parts, which is related to exploring the code flow in general from end-to-end perspective using the logs, and we give some examples using the logs and traces. And the second one, where we have a breakdown for the top failures for these 3 categories. So this was the first 3 sessions. Then the second part, we moved through the 5G non-standalone planning. We covered the first 2 points, which is related to 5G non-standalone slot format and the planning related to the frequency, IRFC, and SSP planning. And all the below were being covered during these 2 sessions, where in-depth knowledge being shared during these 2 sessions. The remaining sessions will be 1 or 2 for the NSA planning, which will be covering these mentioned points, PCI neighbors, and RATCH and tag planning, and also some consideration during the configuring the downlink transmit power. In today's video, actually, we are going to cover the part related to the K factor, which might influence or impact in general the 5G non-standalone traffic and how we can tackle this. And also the good point as well that we are going to cover the part related to, I will show you some ideas and insight ideas of how to use the Power BI to generate some good useful insights where you can identify, for example, the top revenue sites or top low traffic sites, and also other things, right? The root causes for the low traffic sites. And then the next sessions, the remaining will be covering these 3 points, which is throughput analysis, overview about the NSA latency, and also the main basics of the 5G in order. And this part I have added recently just to cover to have a complete guideline about the 5G non-standalone in general, because I didn't go through the details about the overview and network architecture and even the physical layers and so on. So now let's move forward to see what we have about the third session number 6, which will be covering third point for the K factors or can influence or impact 5G non-standard traffic. The first part I would like to cover, it's related to a high-level view of what kind of actions or K factors where it can impact the 5G non-standard traffic. Then we'll go through one by one in more detail. So initially, actually, the first point which we usually look into is something called anchoring optimization. As you know that in general, in 5G non-standalone network, it's still relying on the 4G network as a backbone, right? Because still all the signaling and control plane need to go through the 4G network. So this is actually the 4G node will be called as an anchor. So we need a 4G layer to be defined as an anchor for the 4G for the 5G to start like getting 5G non-standalone traffic. So we'll define what kind of optimization action can be done for that part to optimize the camping or the anchoring in general. The second part, actually, it's about aligning the physical design between, for example, the anchor layer, which is, let's assume, FDD, and the NR as well. For example, if it's having a different orientation, can impact the traffic because you will have a misbalance or, and for example, the coverage footprint. And the second part that we require X2 also definition between the 5G sites and 4G sites as well. This is very important because if you don't have the X2 interface, even between the 4G and 5G nodes, will cause a problem as well. Second, it's about some parameters to make some quick addition for the SGNB addition, which is related to the also adding the 5G in case of the during the initial setup and so on. This also will be covered in more details. Then it's about load and interfrequency priority tuning. This is also if you have any load balancing going, might impact your performance, and we'll show some example of that part for the 5G, in general 5G camping, so it can be reflected in that traffic. And we have also some configuration from the SGNB side, from the 5G side, can be done, or even from the 4G side, can be done to increase the penetration of 5G users, increase the users accordingly can be reflected. And the last part is related to the power tuning engine. So let's move forward and see what we have for each of those points. So the first part we are going to cover, it's about the anchoring optimization, which is more related into doing some audit, and especially when you have a new deployed network, we need to confirm some inputs which can impact the user penetration, 5G services, and even can reflect in the 5G traffic. So The first part, for example, you would like to check is the current configured radius for 4G and 5G. Assume now, for example, you have this particular scenario where you have the 4G node and 5G node, and both under for sure under the same site, and both can have a coverage up to 7 kilometers as a snapshot. But the radius for the 4G, for example, for this particular site was defined for 7 kilometers, while the radius for the 5G was defined until 5 kilometers only. So if you have standalone users under the 5 kilometers footprint, he will be able to access to 5G because he can get the anchor. Accordingly, he can start adding the 5G. But in case if he's out of the radius of the 5G, he will be coming in the anchor, even though the coverage is being reachable here. When he's trying to add the SSG node B, there will be a failure because of the user crossing the radius. So this can impact the in general the services of the 5G. So this can be reflected in the traffic as well. So you need to ensure that both of them is covering almost the same radius. The second point actually it's related to the physical parameters and particularly related to the azimuth and tilting, whatever you have the network. Assuming, for example, this particular scenario where you have, for example, this azimuth not aligned, assuming that you have already within the same site covering the same area as shown here. For example, the blue one is 5G and the red one is for the 4G. Assuming that now here in this case, the azimuth is for the 5G is like this, so it's covering this area, but the 4G azimuth is not really aligned with the 5G. So in this case, you will have some areas with weak coverage, especially, for example, the area which is falling in the null or in the left side or whatever for here. So in this case, you need to align to try to have as much as you can the same azimuth for both of them to ensure that you have coverage overlapping for the 4G and 5G node. And the third point, it's about actually X2 and neighbor relation in general. As I mentioned, this ANDC in general, it's required to have a neighbor definition, right? So if you don't have, for example, one of the things we are going to discuss in the planning part, you require to have a neighbors definition or frequency definition, for example, from 4G to 5G, where you define the frequency of the 5G and the 4G side. Also, you need a neighbor definition from 5G to 5G. So assuming that you don't have a neighbor defined or the frequency is not defined from 4G to 5G, so for sure you will not get a service. You cannot have adding the 5G once you come in the 4G side. And at the same time, also if the X2 interface having some problems or down or having issues in the definitions, this is still can impact the 5G and you cannot get a 5G service as well. The user will retain only in the 4G site and cannot have the 5G addition. So you need to ensure also the neighbor definition plus neighbor and frequency and the X2 definition. The third part actually, it's like a generic part where you need to look into it. That's 5G power. Usually during using your AAU or the active antenna unit, or even RRH or RU, depend on what kind of hardware you're using. But usually you need to align or ensure that the maximum power is being utilized. But for sure, after considering if any like government or regulation from the government about the maximum power, but in case there is no limitation, you need to ensure that the maximum power is being aligned for both 5G and 4G, particularly for 4G, 5G as well, in order to have more coverage footprint. So this was the first part. Now let's move to the second part. Actually, the second part is very simple. Assuming this scenario where you have this kind of footprint, for example, assume this area you have 5G coverage here, the blue one, and you have the anchor layer is defined for the 4G L1800. And you have within the same site, you have also 4G L900, but it's not defined as an anchor. So if the user is coming in the 4G, in this particular case, he cannot get a 5G because this is not an anchor layer. So in this case, you need to guarantee that all the time, whenever the user having falling down under the L1800 coverage, you need to come in this L1800 in order to be able to add the 5G coverage, to add the 5G service. I mean, so this can be done through different features where in summary, because it's the naming is different from one vendor to another, but for example this naming, for example, it's calling interfrequency for the based on anchor, where the be check the capability if the users or the current configuration, if this layer is not being configured as an anchor, it will directly hand over to the anchor layer and they start having an addition. Also need to ensure another things that, for example, in this particular scenario where I'm going to mention here, assume this is the 5G user. So initially he was here, he was coming in L1800 and 5G, so he's enjoying the 5G services. He started getting, for example, 700. This was average speed. But once he fall or make handover from this layer 1800 to the 900 layer, through load balance. This was load balance handover from 18 to 900 as an example. What will happen once he fall down here? He will start losing the 5G services because L900 is not defined as an anchor. So this is one of the action points also you need to make sure that in general try to avoid any load balancing trigger within the 4G sites for the ANDC users or the 5G capable devices. So this is also one of the points. So the user now will start giving only, as you can see, the 4G speed, which is around 70 mega, and instead of taking the maximum speed was around 700 in this particular case. So this is also one of the scenarios where we have and we need to avoid, especially during the initial deployment of the networks. Now let's move to the second part. This part actually, it's like also again, this is can be done for the network where it's having non-continuous coverage from the 5G, assuming that you have only 50% of the sites in the network where it's supporting 4G and 5G, where the other remaining sites are 4G. So in this case, you can still extending your coverage through this particular scenario. Assume now you have this site on the left side where it's supporting 4G and 5G, while the side, let's assume it's 500 meters away, supporting only 4G only. So see here, we make assumption that the 4G coverage from this site was reaching till here. So once the user move, while the 4G coverage for this particular site was only till this particular area. So once the user go outside this area, he will not be able to get 5G services because only the anchor was being defined within this 4G and 5G here. So in this case, what you need to do, this is what will happen. The 4G, 5G the user will have a 5G until he move to the edge here. Once he move outside the 4G coverage and he move to this area where the anchor is not being defined from this site, he will start losing the coverage. And this is through, for example, defining this site as an anchor on the as an anchor layer. So once you define this site as an anchor layer for this particular 5G site, now the users can start to have a 5G services up to this coverage footprint of that. So this can be done, but you need to be very careful as well because sometimes can be done on top of the B1 threshold tuning because sometimes extending the coverage too much even using V1 can be reflected in some users where they have a limitation in the uplink and deep Indo users where they can also reflect on their services. So this is also need to be done. You need to be very careful whenever you do the optimization, either for the V1 threshold, where we are going to discuss in next slides, or also about in general adding 4G sites only as an anchor for the 5G sites. But this is just an idea, especially for the new network. So let's move forward and see what we have. In this part, actually, we are going to discuss a general, which is common actions, which is usually done from the 5G or 4G sites in order to increase even the user penetration and also can have some increase in the traffic, can influence the traffic. So, for example, the first part we're going to discuss, as you can see, this is SNB addition or configuration in general, in case if you'd like to add the five users. So, for example, you have two thresholds, which is one called A2 and B1 thresholds, and also you have the time to trigger free B1. A2 was a B1 first was for the SGNB addition threshold, assuming that the current threshold is 108. You have it on network, so you can add the 5G coverage up to 108 only. So if you extend it to this one to 112, in this case, you will have more extended coverage, so you can cater or get more users and more traffic as well. And if you tuned also the time trigger, you can have quick addition. For example, instead, or let's assume 320 milliseconds to 16 milliseconds. So this can make a quick addition, but just for quick addition, it will indirectly reflect also in the penetration, but not that much. But in general, extending the B1 threshold can having a very big impact in the traffic. And actually, as you can see in the below scenario here, we assume that in this particular site, this is the coverage of the 5G was that we assume that B1 was only 108. In this case, we extended once you go out of the 108 threshold where we have 109 here or whatever. So in this case, the users cannot get a 5G. But once you extend it to 112 as an example, this what we'll have. You'll get more coverage and more users. It can cater more user or more traffic, even its users. But you need to be very careful because this can have, first of all, you need to understand from the OSS perspective, you might see a degradation in the 5G OSS speed because actually you are getting more, you are capture more edge users, right? So the overall average from the OSS, it will reduce, but definitely will have increase in the traffic and the users. But this is also one of the things you need to consider whenever you do this kind of extending the threshold. The second part that this can have a severe impact in general in the user experience in case if you extended the threshold too much. Assume you make it 125. So you might have a downlink coverage, but you might not have any uplink coverage. You might have a uplink coverage limitation. And we have received different complaints before about that part when you extend it to up to 125, 121, 122, where the user can see a 5G in downlink, but he don't have anything to do in the uplink because of the limitation. So this is reflecting in a very bad experience for the user in general, because this increases the retransmission in the 5G side, and this is kept in this same loop until even the we have a drop or until the service is very bad. So you need to consider also when extending the threshold to make sure it's not extended that much, and you need to make it with proper network study for the current network, even penetration for the indoor and the 4G and 5G coverage, and you do several testing using whatever tools, drive test or indoor, in order to guarantee the optimum threshold where you can use it for the B1. And the same time for the A2 threshold, which is related to the removal. They have different naming, but in general from different vendors. But in general, this is to remove the A2. If the A2, if the coverage of the 5G falls below a particular threshold, you need to remove the 5G. For assuming now we have 112, and this one will be 113. So this means if the user is having a coverage worse than 112 or 113 of the A2 threshold, the 5G will be removed, and this is the A2 removal. The second actually action where we are going to discuss about, it's something called periodic P1 search. Actually, in case if let's assume that the input be delivered the B1 configuration to the users, but the user didn't send any measurement report after. After that, if this periodic is not enabled at all, this can be reflected that the users cannot try again to try to add the 5G even after moving for some time and so on. So actually, so there is a periodic search for that part. This can be enabled, and this can have a duration. For example, you can do it every 30 seconds. So if you reduce it, for example, for 10 to 20 seconds, so in this case, this would be the scenario as shown here. For example, first of all, it might not be enabled on all. So if the RRC configuration being delivered with P1 thresholds and there is no UE reporting nothing here, so the user will maybe stay in the 4G for longer time. But if its periodic is being enabled, though there will be a periodic delivery of the configuration. Instead, if there is no 5G coverage, so again it will deliver RRC configuration B1 for the users here. And once being delivered, because actually the main point that if you couldn't report, the configuration might be removed. So the BTS need to reconfigure this B1 thresholds again. Assume that you have already periodic, but every 30 seconds. So this can take a longer time until you add the 5G. So first you need to ensure that periodic in general is being enabled if it's depend on the vendor specification. Second, you need to check the current intervals. But for sure, this can result also in increase in the signaling in general, in case if there is no coverage for 5G or a weak coverage for 5G or whatever. And here, a scenario where you increased it, for example, 30 seconds. So here, instead of taking 30 seconds to add, here the user takes 30 seconds. He also delivered after the second one, the second delivery, it's around 20 seconds. He was able to report the B1 measurement, B1 report for B1. So the 4G will start adding the 5G side. And for sure the gain that you will have more addition for request, and you will have more users, and also you might have more traffic. But the main disadvantage for that part that it can first of all increase the measurement gap, because the user need to start keep measuring for the 5G, and also can increase unnecessary signaling procedures. So you need to also make sure to optimize the threshold based on the nature of the network, or based on the devices penetration, whether you have routers, you have smartphones and so on. This is need to be considered as well. And here, this is increasing the edge addition can result in general in increasing 5G user traffic, and keeping the user measurement gap regularly. This can impact even the 4G throughput as well, the 4G side. The third part actually is about the SGMP traffic volume based. Assume you have this kind. There is a strategy where the addition in general can be from the initial access or can be based on a traffic volume. If there is a traffic volume being achieved, then the 4G will start adding for example, demand or the 4G traffic in the buffer, which is required by the user to start download or whatever. If there is a threshold, assume it's for example in kilobytes. Let's assume it's 1,000 kilobytes. So you need to have more than 1,000 kilobytes in order the 4G to start addition. So this is one you can even disable it. So to have a 5G from the initial access, or you can just try to tune it or reduce the value based again on the network. And the drawbacks actually that you will have addition signaling due to unnecessary 5G addition in very low traffic scenarios. In case if you have a very low traffic, you will have unnecessary 5G triggering, but this is also might sometimes need to be seen by the users. So this is can be the drawbacks which we have. And again, for sure, you might have quick addition and can be reflected in some few traffic increase. One more point which we have it here, it's about actually the SGNB addition type in general. You have blind and measurement, but this is not really can impact the traffic, but blind addition will have just reducing latency, but this is also result in SGNB addition failures and even block error rate. And you have the measurement addition. This is can have a better success rate, but it can have an addition delay and as you can see, more measurement gap. So this is actually just for informative. Usually we use the measurement part because this is more guaranteed, especially for the success rate. Now the next part which I would like to take you into, it's just some ideas using Power BI to try to identify problematic sites where you have problems in 5G, particularly for the traffic scenario, and also what kind of root causes can be identified from the OSS. If you look into this figure, actually, the right figure here, this is like a dashboard which is being created. It can be done through even any tool, not necessarily to be Power BI. It can be, for example, Tableau. But I will just give you some ideas. For example, here, in general, that the goal for building this such templates was to extract valuable insights from the data which we have, especially from the OSS, which are more accessible and we have more visibility over the OSS because not all the networks supporting different tools where you can check or evaluate the coverage and other metrics as well. So this is the main idea, that to extract valuable insights and to make like decision and optimization with the context of 5G network operation in general. And here, some of the example I would like to give to you. This was a general dashboard on the right side here. Just here, this is was just telling me what kind of penetration the network, what kind of penetration we have in the network for the voice and 5G, even the VoLTE and the 5G traffic in general, how much we have. For example, here we have 22.1 5G traffic, and this was the percentage in terms of capable devices. And here also is giving us like percentage that we have 21.2 capable 5G devices, but we have only 12.6 as a connected users. So this is reflecting that there is a gap around 8% where you need to look into. For example, you can use a metric to identify that sites with high capable devices with very low connected users. So this reflects that you might have some issues on the sites where from the previous actions. So here there's main points which we are going to discuss some of them. Here is just the overall idea for the dashboard, which is showing that you can do that for site, regions, even you can do it site level, cell level, or per regions, as you can see, to check the current distribution of the CS or even base traffic. The second one will be showing about the traffic overview. Let's see. Then we'll about the site level traffic overview. I will be showing an example for that part, and also be showing example for identifying the top revenue sites, where, for example, you need to give a special focus because you might have some sites which is generating huge number of traffic, for example, and percentage of these sites from the overall traffic is very high. So this is can be a top revenue sites where you need to give a special focus and optimization for it because it's giving a high revenue. So this is also a way forward where you can define also an idea for the Power BI or any other tool. And also I will show you some ideas of how to use OSS in general to identify root causes of the low traffic, particularly reflecting if you have a coverage issues in the network or not. So let's move to see what we have as well. So for example, in this particular idea where we are showing here, this we was identifying a 5G low traffic site, the top low traffic sites, as you can see in the middle, in the figure in the middle here. How you done this? We do it based on criteria. For example, the first criteria that we need to check, first of all, what is the current capable devices? Assume that the current capable devices is 30%, and you have a connected users only 5%, and you have a traffic only 5%. So you will check what is the current average in the network, what you have in your network, and you start doing your own criteria to do that. So this was a playing around with the capability, connected users, and traffic as well, just to guarantee that you have enough capable devices, but still there is no traffic or very low traffic or generating a very low having a very low active users or a very low traffic. For example, here our threshold was below 10% for the traffic point of view, and the capable devices was, for example, greater than 25% up to 30%. So this is can be due to the user demand as well, but this is one of the points where you need to look into as well. And here just was giving overview about the overall 5G traffic per site, where you can see what kind of top sites we have and what is the site category, what is the average traffic per site daily, and what is the penetration of the 5G in general, either 4G traffic or 5G connected user. So they can give you an estimation. Then you can start plotting this in the map, as you can see here. You can plot this in the map to see where is the low traffic sites. And this is, for example, the penetration is 0, 10%, and 40%. So you can know which areas generating high traffic and which areas generate low traffic. The second example, actually, it's about the top revenue sites. Actually, this is also one of the very important sites. For example, in this particular region, we filtered on the top 20 sites based on DAX formulas that to identify the top 20 sites with generate traffic. And as you can see, those sites, it was generating only 20 sites out, as I remember, more than 1,000 sites. 20 sites only was generating 10% of the traffic, which means it's having a very high contribution. So this is really require a special focus, because at the end, this is if those sites being impacted, this will really reflect in the revenue and even in the overall network performance. And here was just a breakdown for the sites per TB, terabyte. For example, what was the sites distribution? For example, 298 sites operating with more from 1 to 3 TB and terabyte, and for example, 175 from 0 to 1 terabyte, and 34 sites even greater than 3 terabyte. This can be done site, region, and whatever, but this is work site level, as you can see here. And also you can have a look into the map as shown. The next idea, actually, which is also very good, coverage benchmark users all sets. For example, here we give some metrics using even the 3G network or 4G and 5G network. For example, if you assume you have a 5G site, we use 4 metrics in this area. For example, use something called coverage less than 115 dBm. This is, you have some metrics from the KPIs where you can identify the coverage indexes and coverage redirection. For example, you have redirection triggered due to coverage. During that coverage, we identified the ratio of these sites. This is the overall ratio for the network. And a service C, for example, you have a 3G network, so this will identify, for example, the top sites with service C attempt. So assuming that some sites or even the coverage direction to 3G. So this is you can lose the 5G traffic because unnecessary triggering, for example, to 3G, even during the service C or even using the coverage redirection to 3G. So this is, you need to go and check this particular sites where it's having issues regarding tilting, power, or even configuration. And also check sites with high 3Gbps traffic penetration or 4G, depend on the network, but this was example for the 3G. So this sites also might have, it's having 5G, but as long as it's having a high 3G traffic penetration, this can also reflect that you have a problem still in your existing parameters. And here, this was just comparison reason to know, for example, if any variation between the cities or regions, as you can see here. For example, in the figure on the right, for example, you can see here, this site was high 3G traffic penetration. You find that some sites having penetration up to 30% of the traffic to 3G, which is very, very high ratio. You need to go and check what's happening on this particular sites. Some sites here, for example, and even though the traffic was high, 1.1 terabyte per day, which is highly traffic. So this is can be having a problem. And here, for example, the right figure as well, confirming part of the SRC attempt, we found that some of the sites even generating like SRC attempt percentage is 43%, which means 40% of the calls is being redirected to 3G through SRC. This is also indicating that you have a problem, pure problem, even configuration or parameters or tilting and power and so on. So this is also can, if you fix these issues, you can being reflected in a very good traffic increase, either in 4G and 5G network. And the same example was done for the coverage direction as well. This was just an example for the Power BI, which can open some windows for you for some ideas for the network optimization. This was the last part of today's video. I hope if you liked the video to click like and share it with your friends and to spread the word. And see you in the next video. And thank you very much. Thank you. See you in the next video.